All right, here we go with some solving systems of equations now, Algebra 1. So basically, now we are looking at, like I had mentioned before, when we see a system of equations, that means that there will be more than one equation in one problem. And you'll see what I mean when we get into the examples. So let's just first of all talk about basically the way that we're going to be solving these will look very similar to the bell ringers, okay? Um, so if you can solve these types of problems, you should be okay with most of the work for these. So let's just jump right into it. Now here we go. We're going to start this off by taking, we see some parentheses, so we're going to take this 2 and distribute that through. So 2 times x and 2 times negative 5. 2 times x is 2x, 2 times negative 5 is negative 10. So this is what your first step should look like. 3x plus 2x minus 10 equals 5. Then we combine our like terms. I have a 3x and I have a 2x. When I add those together, I'm just adding the numbers out front. 3 plus 2 gives me 5x. I'm going to bring down the minus 10 equals 5. Now I will start moving things around. I'm going to start with this negative 10. It's a negative, so I'm going to do the opposite and add 10 to both sides. Negative 10 plus 10 is 0. Those are gone. Bring down your 5x. Oh, I changed the color. Bring down the 5x. 5 plus 10 is 15. And then the last thing we need to do, since this is being multiplied right here, we will do the opposite and divide. So we'll take 5 divided by 5 is 1x. 15 divided by 5 is 3. So that's your final answer for the first bell ringer. Second bell ringer. Started off the same way. I got a 6 right here. I'm going to take this 6 and I will distribute that through. 6 times negative 2 is negative 12x. And 6 times 3 is 18. So my first step, negative 12x plus 18, bring down the rest, minus 7x equals 20. Next, I will combine my like terms again. Negative 12x minus 7x. Add those together, you get a negative 19x. Bring down the rest, plus 18 equals negative 20. And again, I'm going through this quickly because this is something we've been doing a lot of, so you should be familiar with these. Next, I will move the 18. This is a positive 18. Do the opposite and subtract. 18 minus 18 is 0. Those are gone. Left-hand side is negative 19 equals negative 20 minus 18 is negative 38. And our last step is to get rid of this negative 19. We are not going to add because it's not being subtracted from x. It is still being multiplied by x. So we will do the opposite and divide. 38 divided by negative 19. Negative 38 divided by negative 19 is 2. All right, so that's just a quick overview of some things that we've already done. Now, this is what our new stuff, here's some notes on what our new problems will be like and how we're solving them. So again, solving systems of equations, we will do this in 3 methods. We've already done graphing. That was in 3.3b. 3.3c is by substitution, and then 3.3d, e, and f are all elimination. Now, think about what the word substitution means, or substitute. If one of your teachers is absent tomorrow, then they have to get a substitute, right? So a substitute is a person that takes the place of your teacher, right? So in math, when we substitute, that just means we're plugging in a value into a variable. So if I have something like 3x minus 5, and I say x equals negative 1, I take that negative 1 and I substitute it in for x, right? We did this in chapter 1, you know, and you go through and solve it. We've done problems like that before. That's nothing new. But now, instead of it being just a number, it's going to be an equation or an expression. Okay, so that's where we take it to the next level. This is our next step of difficulty. It's not just a number that we're substituting in now, it's an equation or an expression. And then if you remember, like I've been saying, and you know, for your systems of equations, our answers are always the form of a point, x and y. So we can't just get one of them, we need both, and our answers have to be written as a point, okay? So let's go ahead and get started with one of these examples. We're going to do 5 examples. I'm going to do all of them with you just because this is a confusing topic. I don't want to have any of them done and just, you know, breeze through them. I want to go over all of these with you. So this may be a little bit longer notes than normal, but it's for a good reason. So this is what we're doing here. These will all be set up for a variable. So we just identify the variable or the equation that's set up for a variable, and I'm going to take this 5x plus 80, and I'm going to substitute that into the other equation for y. Now you might be saying, well, why am I doing this? What's the purpose in this? Well, you can't solve a variable. You can't solve an equation that has two variables. So in order for us to solve this equation, we need to get down to one variable. So we do that by substituting this in for y, and then we're left with just x's. So when we do this, I have negative x plus. Now for y, I'm substituting in this part. And when we substitute in, just like I said back in chapter 1, always use parentheses. Sometimes it's not necessary, but for the times that it is necessary, if you don't have them, it will make your answer wrong. So we want to make sure that we use parentheses every time. Now, we see parentheses, so we would distribute, but this is a case where we don't need the parentheses because we're distributing a 1, which doesn't change anything. So I'm just recopying this now without the parentheses. And then I will go to my next step, and my next step is to combine like terms. Okay, so combining like terms, I have a negative x and a plus 5x. Add those together, what do we get? Negative x plus 5 is 4x. Remember, this is just like a negative 1x. Bring down the rest, plus 80 equals 40. So we're going to keep going here now. From here, this is nothing new, okay? The only thing that's new in this problem is that first step of substituting this in for y. That's it. After we do that step, the rest of this problem is just like what we've been doing in 3.1 and not really 3.2, but all of 3.1, just solving our equations. So after you do that first step of substituting, the rest of it's just review material. So let's move the 80. So minus 80, right now it's a positive 80, so we will do the opposite and subtract 80 from both sides. 80 minus 80 is 0, those are gone. 4x equals 40 minus 80 is negative 40. And our last step is to divide by 4. So we know that x equals negative 10. Now, some of you might be thinking, all right, good, I got x equals 10, I'm done, let's move on. But no, remember, our solution to a system of equation has to be a point. We need the x and the y. So what I'm going to do is now I'm going to take this 10, negative 10, come back up to the problem. Now, you could use either one of these equations. It does not matter which equation you choose. I'm going to use the bottom one because the bottom one is already solved for y. So if I take this, 80, if I take this equation and I plug that negative 10 in here, it's already solved for y and I'm done, okay? So 5x is negative 10 plus 80. Multiply, y equals negative 50 plus 80. Final answer, negative 50 plus 80 gives you 30. So final answer, now we will write our answer as a point. Negative 10 is the x value, 30 is the y value, and that is your final answer. Okay, this is how your answer must be written in order for you to get credit. You will lose points if you don't have it in this form. If you just have y equals 30 and x equals 10, you're going to lose points. Okay, it has to be written as a point. Okay, because the solution here is the point where these two lines cross. Okay, if we graph these, there's all sorts of graphing programs out there. If we graph these, you can see that the point where they intersect will be negative 10, 30. Okay, so I mean, you could check that if you wanted to. But anyway, let me just recap this before we move on to the next problem, because I want to make sure you understand what's happening here. So the first step, because this is substitution, make sure you read the directions. Okay, you have to do it by the method that I'm telling you to. So make sure you're using the equation for that variable. So I'm replacing, or I'm substituting this variable y with what y is equal to. Y is equal to 5x plus 80. Plug it in, and then we go through our steps of solving equations. Distributive property if there is some, combining like terms if it exists, start moving the number that doesn't have a variable, and then divide by the number in front of the variable. Okay, that's nothing new. We've done lots of those. But then we have to remember to finish this out. I need to take this value that I got for x, plug it into one of these equations, and solve for y. Like I said, we could have used the other one. You could have plugged negative 10 in here, and got, 10 plus y equals 40. So then y, if we subtract 10 over, y equals 30. We got the same thing. It doesn't matter. Okay, you will get the same answer. So take your pick, whichever one you like. All right, so let's move on to the next example now. Now, these are both solved for y, so what I'm going to do is I'm going to take this 1/2 x plus 3, and I'm going to plug it in here for y. It's the same thing as if I were going to take this and plug it in here for y. You can see that they're the same. Okay, so I'm going to plug this in right here for y. So 1/2 x plus 3 equals 1/2 x minus 7. So then we go through our steps to solve. Move the 1/2 over. So subtract 1/2 x, subtract 1/2 x, and you can see that we will end up with a problem that is very similar to what we did in 3(1)e. What happens when all your variables cancel and I'm left with a false equation? What does that mean? That means no solution. Okay, no solution. We're done. You don't move on. You don't do anything else. No solution. Now, what this means in terms of the graph is if we were going to look at the graph of this, that would mean that these two lines are parallel. We would have 1/2 x plus 3, which would look like this, and we would have 1/2 x minus 7, which would look like this. But those two lines are parallel. They never intersect, so there's no solution. All right, let's move on to the next problem now, number 3. Again, for number 3, I have something that is already solved for y. I'm going to plug it into the other equation for y. So let's rewrite the rest of the other equation. And I'm substituting or replacing that y with what y is equal to. And y is equal to 3x plus 4. Okay, just like if we said that y was equal to just 3. We would just plug a 3 in there. Or if y equals x, we would just plug an x in. So y equals 3x plus 4, we plug 3x plus 4 in. Okay, it's the concept of substitution is the same. Doesn't matter what we're plugging in. All right, now we're going to multiply this -4 through. So let's see what we get here. So 12x, -4 times 3x is a -12x. -4 times -4 times 4 is a -16. Equals -16. So what happens here when I add my like terms? What is 12x minus 12x? 0. They cancel out. So I'm left with -16 equals -16. What does that mean? Well, that's true, which means IMS. Okay? So infinitely many solutions means that those two lines are the exact same line. Do they look the same? No, they look very different. But if we graph them, they are the exact same line, which means they would overlap, and you really wouldn't even see both lines. You would only see one line. But this is a true equation with no variable. Again, that's the important part. Your variable has to cancel out. In both IMS and no solutions, you can see the variable canceled. And if you're left with a true statement, it's IMS. False statement, no solution. All right, so now let's do a couple more here. So we have 2 more problems that we'll do, and these 2 will work out like number 1. So we'll get some answers here. So I'm taking 4x minus 7, and I'm going to plug that in there for y. So let's rewrite the rest of this. -4x minus 2. I'm going to replace y with something, and that something is 4x minus 7. Okay? Now let's go through and solve this. -4x, take the -2 and multiply it through. -2 times 4x is -8x. And -2 times -7, don't forget your double negative there, is a positive 14. Now we will combine our like terms. What is -4x minus 8x? We get -12x. -4 minus 8 is -12, plus 14 equals 2. Now we need to move the number with no variable, so it's a positive 14. I'm going to do the opposite and subtract 14. 14 minus 14 is 0, so these cancel. Bring down the negative 12x equals 2 minus 14 is negative 12. Divide by negative 12, divide by negative 12, and we get x equals 1. But we are not finished, okay? We're not finished with this, like an infomercial. But wait, there's more. We need to take this and plug it into our equation. So I'm going to use the top one, all right? Y equals 4x minus 7, and I'm going to plug in for that x a negative 1. So y equals 4. I'm replacing or substituting in a negative 1 and minus 7. All right, so y equals 4 times negative 1 is negative 4, minus 7, y equals negative 11. So now we can write our final answer. I know that x is 1. Always put your x first. Y is negative 11. Y goes second. It's always alphabetical, okay? So always write your answers in alphabetical order. If it's an x and a y, or a w and an r, or an a and a b, it's always alphabetical, okay? So 1, negative 11 is your final answer. And if you want to check your work and you want to know if did I do this correctly, if you plug 1 into the other equation for x, you have to get negative 11, okay? If you end up getting something different, then you know you did something wrong, okay? So just keep that in mind, oh, I'm sorry, that was a positive one. Let me back up. This is a positive one here. Positive 1, which would make this a positive 4. 4 minus 7 is a negative 3. I plugged in a negative 1. Sorry, guys. Let me fix that. Negative 3. Okay? So that's what your answer should be. I'm sorry. I plugged in a negative 1. It was supposed to be a positive 1. Always good to look over your work. You catch little things like that, okay? I make mistakes too. We're all human. We all make mistakes. So, you know, double check your work. That's why we look things over before we submit it. All right, last one. If you're feeling pretty confident on this, I want to strongly suggest, if you really want to know that you understand this, pause the video and try it and see if you get the same answer. Okay, this is a very, very tough topic, probably one of the most difficult ones that we will do all year. After we do this, you know, it's pretty smooth sailing with some formulas and stuff for the rest of the year. I'm being honest with you, this used to be an Algebra 2 topic, and it was tough in Algebra 2. Now in Algebra 1, it's even tougher. So, you know, just make sure that you're asking questions. You make sure that you're really trying these. So I would suggest if you want to try it and you want to see if you know how to do these, pause the video and do it, and then come back and see if you have the right answer. So let's plug this in. Or you can just follow along with me and, you know, if you're thinking, I'm not too comfortable with these yet, I need to follow for a couple more examples. Well, we're going to do one more here, and then you'll have some to practice for homework. So I'm replacing the x with what with what x is equal to, 4y plus 9. Recopy the rest of the equation. Now I'm going back to some section 3.1 stuff. Distributive property. 2 times 4y is 8y, and 2 times 9 is 18. Bring down the rest, plus 3y equals negative 4. Now we will combine like terms. 8y plus 3y, that's going to give me an 11y. 8 plus 3 is 11y. Plus 18 equals negative 4. Now I need to move the number with no variable, so I'm going to subtract 18 from both sides. Minus 18, minus 18. Excuse me. Those are gone. Bring down your 11y equals, break out your calculator, negative 4 minus 18 is a negative 22. Divide by 11, divide by 11. Y equals negative 2. Okay? Are we done? No. But wait, there's more. Infomercial time. Now we got to finish this out. I'm going to write down my, remember it's a negative 2. I don't want to plug in the wrong thing again. I'm going to start with my top equation now. X equals 4y plus 9. Replace your y with a negative 2. Let's make sure we plug in the right thing. Double check. Negative 2. And we'll solve this one. So x equals negative 8 plus 9. x equals 1. Now, remember, we want this in alphabetical order. I'm not going to put the -2 first because I solved for it first. It's always x, y, okay? Always x, y. Okay, so again, like always, please, please, please let us know if you have any questions on this. Send us an email, send me an email, private comment, whatever. These are tough problems. I understand that. But you know, with practice, we'll get better at them. All next week, that's all we're doing is practicing these with a quiz Friday just on these, no older material. So we'll do, you know, probably 3 days of just practicing this concept. So I want to make sure that it's extremely important that you're checking your answers each day. I will post the answers to these each day so that you can check them while you're working on them. But you got to make sure that you're trying these problems because these problems will be worth a lot of points. We're talking like 10 points on your quiz. And they're very, very challenging. So keep up with the work, keep up with it. Make sure that you let me know if you have any questions.